Okay, so I'll get my screen up here, and we'll take a look at the two practice problems. Okay. So let's see, where do I gotta go for that? All right. So it should be coming up here in a sec. Boom. Okay. So we got, do you know what it means when it says find the mean, median, mode, and range?
Not really.
Okay, well let's take it back up to the definitions then. Did you watch the video? Because I went through it with an example.
No, I didn't see there was a video.
Yeah, I made a video. It's posted. I mean, it's right below the notes file, like that we're looking at right now. So,
okay.
So after this, I mean, you don't have to go watch it right now, obviously, but after this meeting, you can watch that, and that'll give you a little bit of extra help. But this basically walks you through what each word means, and you know, how we calculate that kind of thing. So for the average, it says we add up all the values and divide by the number of values. So basically, you know, you're taking a bunch of data that you recorded. This example is about test scores. Okay, so test scores is just one type of data that you can record. So to find the average, we just add up all the values and divide by how many there are. So like for Sydney and Rachel here, you can see, whoops.
So you add up all the top, like all the numbers there, and then you divide it by 6.
Right, because there's 6 of them. Okay, so it basically finds, like, if she were to take another test, this is the number that we would expect her to get, because that's the average of all of her scores so far. So basically, it's the same thing as saying the scores she got are the same thing as her getting an 86 on every single test. Like, that's the average. That's, you know, that's what we're looking for. Median is a little bit different. Median is it's like the middle number of the data. It doesn't matter what the other numbers are. You just put them in order, and then you find the value that's in the middle. All right, so for the median, we take Sydney's numbers up here, and we put them in order. So smallest to largest. You see that?
Mm-hmm.
Okay, so we got 71.
80. You divide them by 2.
Right, so because there's not one single value in the middle, there's 2 of them, right? Because we got 2 on this side, 2 on this side. So this is the center, both of them. Then yeah, you average those 2, and that's your median. So you're basically finding what number is exactly between 82 and 88. It's 85. And again, to do that, sometimes if you have an odd number of values, then there will just be one number in the middle, and it's really easy. That's the median. But when we have to do what's called splitting the middle. So we take the 2 values in the middle, we average them, and we come up with the median that way. So Sydney's average, or mean, was 86, but the median, or the middle value of her tests, was 85. And then mode is really easy to find. It's just the value that occurs the most. So if you look at Sydney's 71, 99, 82, 94, 88, 82, we have a repeat of 82. So that's why she has a mode of 82. 82 appeared twice. All the other data values appeared once. Okay, and Rachel's a little bit different. She doesn't have a mode because they're all different. So you don't really say if you know all the numbers appear once, you don't really say they're all the mode, because that doesn't really, from a statistical standpoint, that doesn't really help us. So we just say there's no mode, there's no repeats. That's what that means. So you don't have to have a mode every time. Sometimes you can have multiple modes. You know, if Sydney had 271s and 299s and 282s, then she would have 3 modes. All 3 of those would be the mode. All right, so let's try it out. So on number 5, what would you do for the average fuel economy of Ford models? How would you find the mean fuel economy?
You would add them all together.
Okay, and then what are we going to divide by?
You'd 10.
Perfect. Okay, so we'll just give ourselves some room here. With this one, you don't have to put them in order, but I usually put them in order right away because we're going to need to do that to find the median. Mm-hmm. So this is how I like to do it. You find the smallest one, cross it off, and write it. So 20, and then you just keep going like that. If you cross them off that way, you don't count them twice, or you don't, skip one. So 22, next is 23, and then there's two 24s. So we'll cross those both off, write them both down. Then 25, and then 27, 28, 40. So 27, 28, 40. All right, so we're going to add all those up, and we're going to divide by 10. So you go ahead and do it. I'll do it, and you tell me what you get.
Yeah, I still got 218.
All right, let me try it again.
Wait, what did you get?
I got 254. What did you get?
254 is when you like add them all together, right?
Right. And then you have to divide by 10 because there's 10 values there.
And that's 25.4, right?
Exactly. That's 25.4.
Okay.
So we're going to put that in here. 25.4. All right. And fuel economy is usually in miles per gallon, but you don't really have to put that. I didn't put that in the problem. I really should have. But as far as labels go, all of the Ford models have an average or a mean fuel economy of 25.4 miles per gallon. So that's what that means. Okay. So now let's find the median. Hopefully you've got them written down in order. So let's see, can I do two at the same time? That'd be cool. No, I can't. Okay. So basically when you have, this is what I do. When you have an even number of values like we do, we have 10. I just divide that in two and then count in that many until I get, and then that'll help you find the center too. So if there's 10, we're going to count 1, 2, 3, 4, 5. Okay, the 5 and 6, those have to be our two middle values. Okay, so what's the average of these two values?
24.
Right. All right. This one was an easy one. They took it easy on us. So median is 24 mpg, because if you add it up, 24 plus 24 divided by 2, you get 24. So okay. So you can see the mean and the median are a little bit different, but they're pretty close. All right. And remember, what I was talking about up here is if a data has outliers like this one does in number 2, an outlier is a number that's like way off from the rest of them. So you can see like the number of students in my classes. Well, this was my data from last year, but I had 5 classes and I had 1 study hall, and the study hall had 15 or 45 students in it. So this 45 is an outlier. You can see with 5 of my classes, they're all between 11 and 15, but because I have that huge number in here, the average gets pulled up way higher than it's supposed to be. So with an outlier, when there's an outlier present, the median is usually the better measure of central tendency to use. 13 makes more sense for the center of my data of students I have in my class. The only reason the mean is so high is because we have a really, really high number there. That's because it's a special situation. Okay, so this 45.
Is that like in ours, how we have a 40?
Yes, kind of. Yeah, 40 is like everything's between 20 and 28, and 40 is way higher. So that's the reason that the mean is higher than the median. So it might be a good idea to use the median to represent the middle of this data instead of the mean, because we do have that one car, maybe it's like a hybrid or something, that gets really good fuel economy. That's kind of, it's skewing, it's called skewing the mean. It pulls the mean higher than it should be because it's a really high value. The median is nice because it doesn't matter, like all these values out here, doesn't matter what they are. This could be a 40 or it could be a 400. It's not going to affect what the median is, which is, so the median is unaffected by outliers and the mean can be affected by outliers. Okay, so the mode should be easy to find here. What's the mode?
24.
Right, 24. It appears twice, and that's the only, whoops, can't write with that. Okay, the mode is 24. And then range. Do you remember how to find the range?
Not really.
Okay, it's just basically the span of all the values. So how many numbers are there between the largest and the smallest? So it's the difference. So you take the largest number minus the smallest number. And when they're in order, that's easy to find. There's the largest, there's the smallest. So we do 40 minus 20.
20.
And our range is 20 miles per gallon. So all the cars in our data set fall within 20 miles per gallon of each other. Okay, And like I said, the best measure in this case would probably be the median, because there is an outlier of that 40 that's really a lot higher than what the median is. Okay, so what can we say here? Median, because
there's
40,
an outlier.
Yeah, 40 is an outlier, or there is an outlier, either way. Awesome. Okay. So now that we've done one together, I think you can probably do part B on your own. It's the same deal, just different numbers. Okay, so why don't we'll skip that and we'll talk about some of these in here. I did a couple to get started on the video, so I'm not going to do the same problems. I did a couple. I did the first two on number 1. So let's go to something that's a little bit harder, and we'll just kind of do a couple together.
I was mainly confused on like 4.
Oh yeah, 4. These are tough. Okay, so and that's really why I wanted people to come to the Zoom session. I thought maybe they would get a little help with these. So okay, so basically you have to write an equation for number 4. Jill had a mean score of 80 on the first 3 math tests and a mean score of 90 on the last 2 tests. What is the mean of all 5 scores? So if the average of the first 3 is 80, then we can just pretend that all 3 of those tests she scored an 80, because it'd be the same thing. Okay, think about it this way: if she scored a 79 and an 80 and an 81, those would add up. Those would all average out to 80 anyway. So what we're going to do is we're going to take the first 3 tests. Let's just say that they're 80s, because that was the average anyway. And the 4th and 5th tests averaged to be 90. Okay, so what is the mean of all 5 scores? So basically we want to take these 5 scores, add them all up, and divide by 5. So this would equal, what is that, 240 plus 180. 420, all right? And then we're going to divide that by how many scores there are, which is 5. So divided by 5.
84.
Right, 84. So that's the average of all 5 of those tests. And that should make sense. We expect it to be between 80 and 90, but it's going to be a little bit closer to 80 than it is to 90, because there's 3 80s and there's only 2 90s. So that's exactly what we get, 84. So okay, so back to the directions. Always important to read the directions. Write the letter of the exercise, so that's D, in the box that contains the number of the answer. All right, so if our answer is, I always like to write the letter next to it so I don't forget. If there is a mistake, I know where to look. So we're going to put a D in box 21. Okay, so let's try exercise A here. For his first 4 bowling games, Abercrombie had a mean score of 100. Then on game 5, he scored 120. What's his new average? So what do you think you do here?
You add the 2 together and divide by 2.
Right, but the first number, 100, that's not just for 1 game, it's for 4. So what do we do up here?
You would add them all. So you could do 100 times 4 plus 20.
Yeah, perfect. Or if you really want to write it out the long way, now you that was great thinking. You used a shortcut, but we could say, okay, so he bowled 5 games. These are the scores of his 5 games. Okay, so we just do the same process here. All right, so go ahead and see if you can come up with that answer.
104.
104, right. If we look at these answers, 104 is or actually 108 could make sense, but 104 and 108 are the only 2 it could possibly be, because we expect it to be between 100 and 120. So let's see, circle this. That's an A. And then we put an A in box 8. Okay. Oshkosh had scores of 76 and 77 on his first 2 math tests. What score does he need on test 3 to pull his mean score up to an 80? All right, this is where you have to set up an equation. This is tricky. So I'm gonna copy this and bring it down here. All right. Okay, so basically we're saying he took 3 tests, right? He got a 76, he got a 77, and then he got some unknown value. So we do know that, let me write it up here, X represents his third test because that's what he hasn't taken it yet, and we don't know what that's going to be. However, we do know that he wants his mean, the answer, he wants the answer to be 80. So when we add up his 3 tests and divide by 3, we want to get an answer of 80. So we have to do a little equation solving here, which is kind of cool. All right, so if we're going to solve this for X, then first we got to get rid of that division by 3. So we're going to multiply both sides by, multiply both sides by 3. That was a mess. All right, and that'll cancel out the division by 3 over here. We get 76 plus 77 plus X equals, and then 80 times 3 is 240. Okay, so what do you think we do next to solve this?
Add 77 plus 76.
All right, combine like terms. All right, so punch that in real quick. 153 plus X equals 240. Okay, now what? Got to think all the way back to equation solving. Get that X by itself.
You would divide.
Not quite. Remember, do the opposite. What
Subtract.
operation is right? We want to subtract. It's a positive 153. We want to turn it into a 0, or in other words, it's being added to X, so we want to do the opposite. All right, so that's going to give us a 0 here. Subtract 153 from the other side to keep it balanced, and that should give us the test score that we need to get to bring our average up to an 80. All right, so what'd you get?
Hold on.
No problem.
$225.
Does that sound right? Can you get a?
No.
I think you left off the 3. Check your calculator. See if you just typed in 240 minus 15.
Yeah.
Yeah. All right. So calculator error. That's okay. It happens. Because he can't. Well, I mean, we know that's not right because he can't get a 225% on the test. 87. There. That makes more sense, doesn't it? All right. So we're gonna find 87. Circle it. See, they throw in these other numbers here and here to throw you off, give you something close. So you got to really be careful. That's going to be an X. So we have an X in our answer right here. All right, let's go ahead and do the last one. I'm sure this video will really help everybody else in the class. So glad he came. Okay. Oh, this is a good question too. Okay, the Flicks Theater sold a mean of 472 tickets per day last week. How many tickets did the theater sell altogether last week? Okay, so if their average is 472 every day last week, how many days are there in a week?
7.
7. So basically what they did is they took some number X, they divided it by 7, right? Because X would be like the sum of all the tickets they sold for the entire week, right? If we took the 7 days, added them all together, that would be X. So if we're defining our variable, X equals sum tickets sold. Okay, add them all up. So, and if we divide that by 7, it should give us the average, which is 472. So all we have to do is multiply this number 472 by 7. Okay, so basically we're saying they sold, instead of knowing the actual numbers, we're just saying they sold 472 tickets every day last week. So if we add 472 to itself 7 times, we should get our answer. So in other words, we can just multiply it by 7. So 472 times 7, 3304. All right, so tickets sold, that's the number that would give you an average of 472 if you divided it by 7. So here's our answer right here. We're going to put an N in number 23. Okay, so it's starting to come together now. What did the boy bumper car say to the girl bumper car? Well, we don't know yet, but got a good start. And those are tricky, so I really did want to work through all those on the video just for everybody else's sake. So I'm glad you came and asked some questions. Do you think you can handle the rest of them?
Yeah.
Good, good, okay. And remember, if something's not matching up or your message doesn't make sense at the bottom, just send me a screenshot and I can help you out with what you did wrong. Okay, but you got to send me your work too, so make sure you're showing your work on it.
Mm-hmm.
You always do that, so I'm not worried. All right, anything else?
No, thank you.
Okay, well, thanks again for coming, and it was good talking to you, and have a great week.
Thank you. Thank you, you too. Bye.
Bye.